Here we go. Okay, so kicking off our advanced JavaScript topics, we're going to get into some more of like the fundamentals of JavaScript that have to do with, some of the really important principles that are, by the end of the course you should be super familiar with at the ready to respond to, JavaScript interview questions and things like that as you go out into the real world. So and then you're going to be using these principles over and over and over again and throughout all the exercises from here on out. So you've just done the JavaScript basics, you've gotten the basics down, a lot of syntax, a lot of the important, basic fundamentals, sort of a platform, and now we're going to add on to some of the really good features of the language. But first, so I'm going to start with a little bit of review and move forward from there. So let me organize my Zoom stuff so that it doesn't get in the way of the recording. Just minimize that. Okay, can you guys all see my Chrome browser?
Yep.
Okay. All right, cool. So what I'll do is I'll actually start in JS.bin and then we'll move over to the Chrome console in just a minute. Okay, so let's see. There we go. All right, clear the console. Okay, so first thing we're going to talk about is sort of to drive home some of those really basic concepts is the idea of arrays. So the two major like data structures in JavaScript that we use over and over again are arrays and objects, right? So we have this idea of const foo, well, let's call this something like my array equals an array, okay? And then const my object equals an object. Now, an array, just to drive this point home, is actually an object that is treated differently in JavaScript. So it's sort of our way of organizing sort of a mapping system to a data structure that exists that we can basically automatically gain a keyword for or a reference to an index in that array or a reference to a spot in that array's memory. So 1, 2, 3. If we were to sort of think about this conceptually, we would get, let me just get a little draw tool. We would get out of the box these 0, 1, 2 indices. So just driving that point home, that's really basic, and that's less of what we're talking about right now. So, and what's cool about arrays is you can actually you can have an array of basically any type in JavaScript. So it can be a number, it can be a string, or foo, or a string representation of a number. It can be a Boolean like true. And it can also be another array, right? And it can also be an object. So this can be, nested as deep as we want it to be. And I think, you get the point. We can have, as many deeply nested arrays as we want. So, and then, other cool stuff, if we have an array full of objects, that's very, very much what you're going to be doing, especially when you're working in the client side, is sort of building. Let's say this is our users, right? So users in our database. And so you're going to have objects like, okay, so the username, is going to equal Fred, right? User email is going to equal, sorry, I should probably actually, and I'm doing double quotes to demonstrate this right now because this is sort of an example of what we call JSON, JavaScript object notation. And that when we get further advanced and further into this stuff, this is essentially what all servers today, it's sort of a really base standard for delivering data across URLs. So when we get more into that, we'll let you know. It looks like we have a couple. Can you have an array of functions? Yes, Brandon, you can. I'm gonna, yeah, as you send messages, it's probably easier to send them over to Slack. I'll have that window open all the time. I won't have this little chat group window open. So yes, you can actually put functions in an array, and I can show you that. So and then email would be like me or Fred at flintstone.com. Okay, so this is very, very common to see this type of a set here of data. So that would be the index 1. And then, right, we would have another user that's username is set to whatever. So that's a very common pattern. Something you're going to be using over and over and over again are arrays. And so the question came up if you can actually add a function to, to an array itself, and you actually can. So you could put this as an index that, simply console logs, hello, whatever. So yes, functions can be properties, can be indices on an array. Right now, just some quick, observations. Let's go through this real quick and just say we have an array of strings, right? So one of your coding challenges dealt with an array of strings, and we're going to be kind of in string land for a while as we go about these coding challenges. So, and then bang, cool. So this is organized data. So if we were to log this out to the console, right now, it's not very useful as is, but yeah, we can see that in memory we have an array set to users, and actually I should probably change this to strings, or even better, to be more specific, string array. Cool. So now by itself, an array, all it is just sort of like a backpack. It just holds, things inside the backpack, and you reach inside the backpack to grab stuff. And because we have these indices that are, instantly assigned to these properties, we can easily index. So if we wanted to index, string array at 3, we'd instantly be able to have access to that. As we go and run it, it's the third index in the array. So counting from 0 based, 0, 1, 2, 3, we get bang. So, and then obviously you guys have seen things like string array dot push. We could say buzz, and then when we log this, we should, so that actually returns the length of the array when buzz actually push actually runs, it returns the length of the array. And so, if we actually just log the string array at this point after we call push, we should get buzz. So very simple stuff. Okay, so now you guys have already seen for loops. So if we want to access each index through a continuous loop, a program that loops from start to finish given the parameters that you give it, we have this idea of for loop. So let I equal 0. We're going to start at the first index in that array. Okay, so that's what we're telling our for loop program to do. And we're going to tell it to iterate I is less than string array dot length. So iterate the entire length of the array, and then I iterate one piece at a time. And so as we go through this, in fact, a lot of times you'll see I in for loops when they're looping over arrays, because it's referring to that index. So all this would do, if we were to console.log I, is going to give us a count. So if I were to save that, and it's just going to give us our indices, because this looped 4 times, started at 0, and then added each time. It's just going to go 0, 1, 2, 3. It's just going to give us the indices. So that's how we index string array. We can look at the given indices at each single point, because I is going to update every single time it passes. We can be confident that every single step in the array until this loop finishes, we can look at the actual result of the array. So now we can look at the actual indices of the array, the values that exist. So once again, just to drive this home, at 0 is foo, at 1 is bar, cool, and then so on and so forth. Cool. So when we want to basically craft an algorithm that has a need to have a little bit more control, using a vanilla for loop is very, very common. So as you go about your toy problems, if you need explicit control over what's what's happening over as you iterate over your arrays. If you need that control, use a for loop just as it's written above. Now, if we don't need that control, but we know all we want to do is just iterate over the entire array, and we're only concerned about the items that are in that array at each specific index, we have this built-in JavaScript property called for each. And it's a method that's chained onto the array dot prototype. So if I were to console.log this giant array keyword, so all arrays in JavaScript are going to have this ability. So if I were to console log that, it's hard to do without the actual Chrome console. So because the console that's built into JS.bin is not necessarily the same. It behaves in a lot of the same ways. Here, let's clear this. So clear, cool. We're all clear. So if I were to just say in the console array.prototype, we can look at what we get out of this array. So out of the box, we get all these cool things, okay? So some of the things that we get are, like I said, this for each function. Now, and then we get array.includes, array.indexOf, array.join, array.keys, which is very interesting because it's an object, still inherits that keys property, and we'll get to keys in just a minute. We've got reverse, we've got shift, we've got slice, we've got sum. Get yourself familiar with all of, as many of these as you can throughout your career. I don't know all of them, and I've been doing this for quite a few years, but I use probably the majority of these in any given day at a real world production environment where I'm building applications. So I've used filter. I use that a lot. I use, find is pretty new, but I've used it. For each I've used quite a bit, all the time actually. Includes I use all the time, but it's newish as well, so you need to polyfill it. Join, and you can go to MDN, you can go to Mozilla, and you can look at what each of these does. If you just go to Mozilla and search array.prototype whatever, so index of for each or whatever, you'll get the whole entire JavaScript spec or specification documentation on this stuff. So I'm just showing you right now, logging out the array prototype, what happens. So to do this, all I did was call array.prototype. And a prototype, just a high level before we get into it later on, a prototype is basically an object that every single object in JavaScript delegates properties to. And we'll get to that later on, so just know that's the high level definition of what the JavaScript prototype is. So we can use, because I have set this equal to an array and JavaScript knows that, we can use string array and inherit the prototype methods. So string array dot for each. Okay, so let's talk about for each, because in your homework coming up with this assignment, you're actually going to be making a clone or like a simplified version of for each. Okay, so what it does, it's a method in JavaScript that takes a callback as its parameter. Okay. Now that callback can be, pardon me. Now that callback will simply execute every single item in the array. Okay, so for each item in the array, call that item back. Okay, so we can actually pass this callback whatever we want it to be. It's going to be our variable or our keyword that we look at on each pass. The same way that we do for let I equal 0, we can actually set an I as a variable that starts at 0. We can actually set that, well, I'm just going to leave that there for reference, maybe just comment it out. We can actually set what the value of every single, every single index of this array is going to become. So the first pass, value will equal foo. So if we console.log value, okay, first pass through, value will equal foo. Second pass, it'll equal bar, and so on and so forth. Up until we finish the end of the array. Now you cannot just come in and hack this and say, I want this to iterate X amount of times, or I want it to iterate backwards. So that's why we use vanilla for loops when we're, it's really important that we have control over our data. So our data comes in as this array, string array, and then we call for each. So for each value, just give us that value. So we're going to actually run this and see what happens. Okay, so same thing that we did with that for loop. Originally, we got, let me just clear the console so you can see it, we got all of the indices out of the array. So this is a very quick and dirty and easy way, it's not even dirty, it's totally standard and totally usable for you to iterate over an array of whatever. So if we had an object in here that said name equals Fred, and I'm actually going to change this back since we're not worried about JSON. It's better standard to use double quotes in Java or single quotes in JavaScript, especially when you're setting data and stuff. So that's all I'm doing there. So now you can see that we have this object that sits on that property here, and with the name and with a property name and a value of Fred. So very common to use for each to loop over some data that, say, maybe you're getting back from an API call to a server. Okay. So for each, very awesome. One thing that you do need to understand about for each is that if you change any of the values, it will manipulate the actual array itself. So that's one thing that if you're ever asked in a JavaScript interview, so if we just chain on to this, and this is a super contrived example, we chain on to the value and we return that, and then we, console log after the for loop runs, string array, we're going to expect that every single value gets a concatenated one string on it. Or one thing that's cool, yeah, I can do that too. So I'll clear this and I'll run it. Didn't quite do exactly what I wanted it to, because why is that? Plus equals 1 because it wants to do that. So not quite exactly what I thought it would be doing, but if I just said, well, because I'm not actually doing true concatenation here. So, but just know that if I were to have like an array of numbers, oh, I know why. Because I don't have closure, and we'll talk about that in a minute. So I can come back to this example in a minute when we get to a different topic, okay? And, well, I mean, I can, no, we're good. So I won't actually do that yet. But yeah, so it will manipulate the values and then give you some sort of side effects or mutation of this original array's values here, okay? So because of that, it is easy to get into some traps when you're setting or updating data. If you're using for each, there is an issue there. So, and then one thing that's also cool is the next parameter that you can pass this callback function inside here is an index or I, or however you want to represent this. So value can be anything. So to demonstrate that, I'll change value to equal element, so like for every element in the array. And then I'll say right here, I'll say console log, so we can actually see this in the console. Okay. We want to console log the element and the index. So the index, the second value that you pass this callback, and yeah, Ali, maybe it does work with backtick syntax, but it should be doing what I want it to do at this point, but I know why it's not working. So we'll get to it. Thanks. And then, so yeah, now if I call for each and I run this, the second parameter, the second argument that you pass this callback that gets called back every time is going to be the index where the element is found. So you'll see that foo is found at 0, bar at 1, baz at 2, bang at 3, object is at 4. So pretty nifty. Two parameters you can pass your for each function, and you can get that those specific values. So if I just wanted to console log, the indices or whatever, or keep track of, each index or whatever, that's a very important thing to understand. So, but just remember the difference between this and the next method I'm going to go over is that this one actually creates side effects. in that it mutates the original array. So for each will mutate the original array if you're actually updating the values. Okay, so I'm going to save this and paste this example file for you that I'm creating as we go. So I'll be giving you the example in the browser and then creating a file of notes as I go along. Okay, so now I'm going to talk about the other methods. So let's go back into our Chrome DevTools. So when I run Command Option J on the Mac on my keyboard, that's what pulls up the console for me. So pretty nifty. And let's look at the array prototype, and let's look at another method. So you can see just right on this prototype, there is a map function that we can use. And just remember, it's a function, and you'll see that right here as the definition. Whoops, clicking on everything. So as we pull this up, get a little bit larger, you'll see map exists. So mapping over an array is pretty much the same thing, except it'll return a new array. So you can treat string array dot map the same exact way. So you're going to pass it a constructor or a callback function. You're going to give it the arguments of whatever you define. So element, L, item, whatever you're looking at, and then the index where that item lives, or I. And then if I were to simply console.log our item and its index, we would expect to get the same exact results in the console. Now, what's different about it is the cool thing about map is that it will actually create a new array of elements. So when you pass item and I, so when you pass each of these products here of your iterator to, oops, I wanted to use this. So when you pass foo to the callback, and then you pass its index to the callback as well, what's going to happen is underneath the hood, map is going to create a new array of these elements and then return that. So foo, and the glory of that, is that at index, well, the glory of that is that you get no side effects from running map over your function. Sorry, this is terrible to write with. But yes, so that's the importance of understanding what the difference between map and for each do, is that you're going to be using both of these functions all the time, and one of them you want to create a new array of elements so that you don't mutate the original array. So map will actually return a new array of the past in elements. Okay, so when you get to the homework and you're going through it and you're thinking about how to recreate map and for each, your for each and map functions are going to behave very similarly in that you can iterate over the array and then call back the values. So pass the values to a callback on each pass. And then what's going to happen is with map, you're going to get a new array of the elements returned. So let me paste this into my notes so that I can give them to you. Okay. All right. And then just to go over, once again, just to go over this idea of const versus let. When we, because the reason we can do this, assign a reference to this array and then mutate its actual elements inside the array, is because we're not actually trying to reassign the reference of this array to anything else. We're just updating its elements. So that reference is constant. If I were to say, the same, and I think I went through the same example. So if I were to now say string array equals just a string, it's gonna give me errors. Well, they're probably actually in the JavaScript console. yeah, so type array, oh wait, so string array is read only. So just remember that. So yeah, it's read only because we've assigned it a constant, right? And we cannot update string array in any way, but we can update the array that string array keyword or string array variable is pointing to. Okay, so just a little side note there. Okay, so now let's talk about let's just talk about objects. Okay, so everything in JavaScript is an object. We say this over and over again. It's because it's true. It's a very heavily object-based language. And so when you're asked this idea of the JavaScript object, or when you're asked to talk about kind of how objects behave and what they do, there's multiple ways for you to go about object creation. And just know that the object literal syntax, so if I was to create a literal just object, is done with bracket notation, okay? So once again, this is sort of basic stuff, but we're gonna show you how to look at some things in here. So let's update this to say user. And so user is assigned to name. Sorry about that. And I want to capitalize my name, okay? Email, I'll just say Ryan is awesome at ryan.com, not my email. Password, okay? We're gonna say JS, let's just do something simple. So JS for the win, not the wine. Cool. So now we have built this little object. Very, very simple. Okay. It's a user. It's got a name of Ryan, email, password. Cool. Very common, very, very plain and straightforward. If we log that out, we're going to see this object that's right here. Yes, I am recording. So created an object literal here. So what good is an object if we can't actually loop over it and check out its values and play around with its data and maybe update the data on the fly? So one way to do that, and the sort of most vanilla and common way that seems to be sort of going away in a lot of like people's opinions and standards, is our standard for loop. Okay, and when I say this is going away, it's always going to be a part of the language. There's just some strong opinions out there on how to traverse objects, and what these opinions say or whatever is just one person saying this is better practices because we're trying to simplify the language and make it a little bit better and more common for people to use standards. Now, the one thing about JavaScript is there are no like main standards. There's no such thing as standard practices. And because of that, we get this really rich, dynamic language that's constantly changing and being updated, heavily driven by the community that is using it. The main standard or the specification is called ECMA. And that organization is what creates the newer versions that actually make it into the language that your browser can read and interpret. So if there is a standard, you go to what's called ECMAScript. And so for now, just know that ECMA controls sort of what the actual standard is, but like best practices are sort of up to the observer. So when we're using the Airbnb linter in your projects, which is probably driving so many of you insane, you're getting all these linting errors. That's by design. It's because it's somebody's opinion. And a very commonly accepted use of all these practices. So cool. So when I say something like this is kind of going away, it's because not a lot of people are using it anymore because there's some built-in methods to do this type of stuff. So when we're looping over an object, let key in user. This is sort of the standard, or sort of a very common thing that you're going to see in documentation across all, Stack Overflow replies. You're going to see, oh, how do I loop over an object? And this is the vanilla way to do it. This is the way to tell JavaScript to do it in this instance. So if we wanted to, we're console logging user. So if we wanted to loop over and just concern ourselves with only the keys that are on this object, this is what we would do. Now, That's pretty useful because there's this thing called JavaScript bracket notation. And so to reference a key, if I wanted to reference user at name, this, if I were to console log this out, this will give me the actual value assigned to the name property. So I'm gonna hit this, and we're just gonna log this out real quick. So pretty powerful, right? So I can just simply say, hey, get Ryan or get user at name. So now there's another way to do this, and that's at, or the dot notation. Dot notation is sort of a shorthand, but we're going to be, when we're looping through objects, we're going to be using more bracket notation to reference the keys and values. And I'll show you why in just a minute. So same thing. So this is equivalent to, I can't use my keyboard shortcuts. This is equivalent to saying at name. All right. So now if I clear this and run it, we get the same thing. Cool. So the power of this is, say you have no clue what the values are what the property names are on this object. You have no clue that user has a username, email, or password, right? So if you're going to loop over it, you can sort of set this idea of whatever you call this piece right here. You can say let property per t in user, and then we can log out property. And that's going to basically define a variable called property, and for every single property in user, log out that property reference or that name on that property. So the same thing. So I can call this key, I can call it property, I can call it foo, I can call it whatever I want. For simplicity's sake, we're going to call it key because that's kind of what we're concerned with here. So now what do you think is going to happen if I actually do this? Because every single pass through this for loop, key is going to get assigned this, and based on the console logging on the lines that I just had underneath this for loop, what do you think is going to log to the console here on each pass? You guys can put your answers in Slack, or feel free to unmute yourself and speak up. All right, a couple of different opinions. Perfect. Okay. So Stephen wrote value. So and by value, I'm sure he's assuming this property value right here. So for each user, or for each key, so define a key as a placeholder reference, or as a placeholder value. So key on the first pass is going to become name. So on the first pass, this is going to equate to name, which is going to log out Ryan. So whoever, it was Alex and Antonio wrote all the keys. It's going to print out the keys values. Exactly. You guys got it. So this is sort of fundamental stuff. And so yeah, but so stick with me, because there's a really cool way to like change all of this, kind of for let or for var key and whatever. So if I clear this and I run this, we're going to get just the keys values. So now if I just say key, I can get sort of a reference, just so you can understand that key at the first definition, we're going to reference the object itself and pass the key into it, which the first pass is going to be name, second pass email, third pass password. So clear that, we get name Ryan, email is ryanisawesome@ryan.com, password is JS for the win with an exclamation point. So very straightforward. That's a very common way to access an object. So if you had then an array of objects and you needed to then loop through that array, this is something you could easily do. And I'm going to show you an example of that in just a minute. It's going to be awesome. So this has been, there's this new idea, newish, it's the last few years, of actually using a prototype that exists, a prototype method that exists on the object prototype. The same way that we were doing, array.forEach or user.forEach. There's this really cool method that all objects that delegate properties to in JavaScript give. So we can use this idea of keys and simply pass it the user object. So if I were to run this, it's going to essentially, let's see, console.log first. Essentially what it's going to do, it's going to actually give me a new array of keys in JavaScript. So let me demonstrate this to you and see what gets returned out of this. Oh, object.keys. Sorry. The keys is the method. So pretty cool stuff. So object.keys, okay, keys being a method on the massive object prototype. Okay, so object.keys returns an array of the keys that exist on this user object. And the reason that's powerful is sort of twofold. It sort of simplifies what we were trying to do with the var key in, or like key in object and then loop over it. So now, and now we get an array, and arrays are much easier to work with in a lot of instances than actual, let's see, what am I trying to say here? Objects themselves. So if we go, I'm going to just paste the MDN specification about object.keys and sort of get a high-level definition of what is going on with this. So once again, it returns, the object.keys method returns an array of given object's own enumerable properties. So that's one thing that's great, is that it's going to loop through all of the properties in here, and we can just sort of play around with them as is. So very powerful way to access the keys. So then if I wanted to say, for example now, if I wanted to run over this array and say for each, let's say, sorry, this is a little bit contrived and a little bit kind of awesome, I think. So for each property, so every single property, we're going to log out. So this is kind of funny, console.log. Actually, I can do this. I can get us out of this console log, and this should do what I want it to. So for each property, console.log the user at property. Okay, so that seems a little bit contrived, and I'm going to let that sort of sink in for a minute. If our object.keys returns an array of whatever object is passed to its properties, and then we loop over that array, and we then get for every single property, we can then sort of use that to reference the original user object up here and now see the values of each one of those. So if I were to run this, same thing you would hope be expected to return or be printed out. So pretty powerful stuff. If I were just to run, if I were just to run the property now itself, now we're only concerned with the property at each place in this object. Okay, so it's just going to log this keyword or this reference, this property place. And then if we say, hey, user at property first time is going to be name, then we should expect this to log name and then Ryan, email, and then password, or sorry, email, Ryan is awesome, and password, JS for the win. So pretty powerful stuff when you think about it. Whoa, double clicked with my mouse there. So sort of let that sink in. I'm going to use this, I'm going to paste this example in my notes and sort of move forward, because not only do we have this idea now of looping over an array just to access its properties, we have a new kid on the block that's a little bit less used and not quite in the standard. It's called object.values. So just like object.keys performed its operation and logged out the keys, you would expect this to, ooh, you know what? I'm not console logging. That is what's up. Okay, since we're using Babel in ES6, we can do this type of stuff, okay? So since we've selected Babel here as our actual transpiler. So if I were to clear this and run it, you see we now get an array of those properties. So pretty freaking powerful. Also pretty new. So let me post these two links in Slack, object, and then we'll move forward. And then I'll introduce you your advanced JavaScript homework after we get through a couple more principles. Okay, so this you can see is there's a disclaimer at the top that says object.values is an experimental technology. So that's the object.values link. And then the object.keys link is right here. So as we're using ECMAScript 6 throughout the course, you're going to be given this opportunity to use this keys or this .keys and .values wherever you want them. Okay, so you don't need to necessarily worry about that. So where is this handy? Where is this useful? Let's say we got a list of data and Ryan. Okay, so we got a list of users. So in the real world, just a high-level English written algorithm here. We're going to say Ryan, as a user, logs into account. Let's just assume he's logged into his Facebook page. Ryan submits new password. Okay, so we go through that whole process. Now on our side, we need to take user.name. So find where user.name equals Ryan, and then change that user's password, right? So you'll be doing stuff with this object.values, object.keys in a very fast and common way to do this. Now, this is pseudocode and it's very high level English written stuff. But if we had this object, say on the client side, and we, and by the client, I mean like in your web app, your browser, in your JavaScript on the client, okay? Client means browser, just for all intents and purposes. So in our, if on our client, we wanted to update some sort of object as it came in, where all properties equal, whatever, some string that's passed in or given, some condition exists where we need to update the properties. So anytime we find like maybe some corrupt data or something that shouldn't exist anymore, we can just delete it right out of the system. So pretty contrived example there, but you'll get to that later on. But for now, just know that object.keys and object.values are very powerful and commonly becoming more common in the specification, the documentation. So, okay, so let's get to this this other principle called closures. So, JavaScript is pretty freaking powerful in that there's different scopes created per function that's created in JavaScript. So each function creates its own scope, and scope is essentially there's this idea of scope that basically says function X has access to X, Y, and Z functions, variables, whatever. So if I just sit here and I say const foo equals bar, I have created this object or this string reference. So I've created foo as a variable and I've assigned it the reference of string bar. Not a very useful program, but so if I console.log foo, you would expect that bar prints, right? I almost console.log bar. That would be cheating. So you'd expect that bar prints. So JavaScript knew about bar because I set it in memory. And it knew about it as well because I actually gave it access to it. So every single time you're writing JavaScript, whether it be in a file, and then wherever you're executing that, you get this context called the global object, okay? And in a browser, the global object is called window. So if I just go in here and I say, hey, window, show me your window, you get out of the box this giant JavaScript object that's built into Chrome, built into Safari, built into wherever JavaScript runs. There has to be this global window object. Okay, so if I were to try and find, so let's do this, window.foo, see if it's not there. Okay, so now if I say, because it didn't say when I opened it, so if I were to say const foo in here, bar, and I were to say window.foo, still undefined. Why is that? That should not be the case. It should be there somewhere. Window dot, it's going to be forever to find it, but I should be able to reference it that way. Anyway, contrived examples for, not for the win, for the loss. So it's not on the prototype, it's just should be there. Anyway, just know that this foo gets assigned that context, okay? It gets assigned this, you know, we can access it and run it and use it. That's why when we hit console.log, it knows to find foo somewhere and then log out that value of foo, okay? So now what happens when we create our own function? So const, let's call it add, and I have an example written down here so that I can follow along with, you know, make sure that we give this, you know, sort of a good run at it and make this as clear as possible. So if I were to explicitly set a variable called name and say console.log in here, and you know, let's be fancy. Let's say hello variable reference name. Okay. So a pretty useful function that just simply logs out the name passed to it, so the name variable. All right, so if I were to actually call add and pass it Ryan, you would expect very commonly this to log out hello Ryan, okay? So now what if this name variable was not actually defined within the scope of this function? What if, you know, so it's defined because I pass in Ryan there, right? What if we just called this now? It's going to give us an error, right? So it'd be, okay, so JSBin output, whatever the output is, it's going to, so thanks JSBin, you rock. So let's see what name gives us in the actual console. Oh, saying the same thing. That's funny. It inserted, name was undefined, so it inserted its own name. That is bizarre. That is outlandish. So, but what if up here we were just to say const name equals, whoops, Ryan. So now we've created a new scope, a new lexical environment or context where this function executes and runs in. And name is, you know, now a variable that we're going to have some sort of reference to. So what's cool is that because this name exists on that window object, I have a closure around the name variable inside of this function. This is probably the most simple definition of closure that you can get. So there's so many contrived examples of closure out there that sort of lead you on this idea that closure has to have an inner function. So just know that closure, if I were to sort of put a high-level definition to it, is a lexical scoping environment that has access to the outer environment in which it's defined and executed. So what the crap does that mean? Basically what it means is that I have created a function that has its own lexical scope, right? But because I've done that inside the global environment of here, of this entire window, I have access to whatever variable is defined outside of it. So if I were to change this to a let, because I'm going to update it down here, and then after this function call, I say, you know, now name equals Fred, and I run this, I'm reassigning Fred, and then I actually run this function again, you would expect that this outer Fred is going to be changed, or the outer name is going to be changed to Fred, and function called the second time should then give me the new name. So hello Ryan, hello Fred. Now, that is, if you ever go into a job interview and they want you to provide an example of closure, this will suffice. And the person may sit there and be like, that doesn't have an inner function. And you can do something like this to show them. You can say console.dir. In fact, I'm going to probably have to do this in Chrome and outside of JSBin. So let me get a new tab open, actually, because Chrome will have this more powerful. So if you're sitting there in that interview and they're like, that's not an example of closure, dude. There's no inner reference. So if you were to log this, just the function definition here, and open it up, you could pop open this scope of the function and find that there's actually a closure in here that says, hey, this inner function scope has access to that outer name, so you're wrong. This is actual closure. And like I said, it's probably the most simple example of it. So you can see, I want it to show that, well, so you can see right here, you have two scopes. You have the scope inside the script that we posted, right? So inside this script right here, this function, and then the global scope in which it was defined in. So you have two closures. And then because of that, you have access to that name variable inside of your script. So that's a great example of closure. So keep that in mind, like, if you're once you ever get the opportunity to show closure to somebody else, that's probably the most simple way. Now, you're going to be doing this stuff all the time, defining variables that are in the outer scope of the function in which they're used. That's programming in general. That's why JavaScript's so powerful, is you can provide access to that. You can gain Ryan from name inside the inner function here. So now let's look at a more heavyweight example that's going to hopefully show you a more, a bigger definition of it. So I'm going to paste this code over here and keep notes for you. Okay, so now we want to let's do another simple way. So let's say const number equals 4. Okay, and let's say that we have a function. In fact, I'm going to use the actual function keyword here. And the reason being is because the arrow function and the function keyword actually behave a little bit differently when it comes to creating a lexical scope. Now, you can both inherit properties, but when you start using the keyword this to sort of put pointers to variables on your actual constructor function that we're going to get to in probably tomorrow, we're going to have a lecture on this and things like that. It's more common to use the function keyword. So when anyone ever says the function keyword is gone, that's not true. It's actually very much still a part of the language, and it's because the arrow keyword and the function keyword behave differently. And I'll get a better definition example of that to you later. So if we said like, let's see here, function. Well, let's start with a lexical function or a fat arrow function, and let's move on from there. So let's say const add numbers, and you just saw a lot of this with your homework, right? On the basic stuff. And I'm just, making sure we piggyback off of those examples. And we say, outer, this number right here is not defined. So let's say let inner, equal to. In fact, let's call this add 2. And then we're going to return inner plus outer. So very simple example once again. If I were to call add 2, we still have access to number. Sorry, I said outer, I meant number. So we still have access to number through within here, and this function is going to return a new value. So if I console log this, and I run it, it's going to give me 2 plus 4 equals 6. So that's the value of inner that's defined inside this function plus number. So if I were to say console.log inner, just a thumbs up or a thumbs down in Slack if you think we actually can do that. Do I, in this outer scope, have access? So in the console, do I have access to this inner variable where I'm calling this? Nay. Beautiful. You guys get it. So we do not have access to inner. So it's going to be an error. Inner is not defined. So that just means there's no such thing as inner defined. But if I were to put this up inside here, you would see that inner is going to give us, did I not save? Console.log. Oh, inner became 6 as well, so it's just shortcutting me. Sorry, inner returned at that point. So I can't console log after the return. So classic rookie mistake. So now you can see inner is 2, then inner becomes 6. We return that number out of it. So we have access to these things inside based on the lexical environment in which they're defined. And then what's cool is we provided a closure around number by defining this function in the outer scope. So where is this actually going to be useful? I'm going to actually refactor this code a little bit to say, to use the JavaScript keyword function. So sorry, I'm going to say function add to and get rid of the const. And then make sure it knows that it's a function. And then I'm going to, so I'm going to actually change the name of this to add stuff. Okay, pretty robust or pretty lame function there. So if we actually are going to define a variable, let's say we want to use this function over and over and over again. Okay, so we're going to pass it a parameter of passed. So whatever gets passed to this function, it's going to hold on to that parameter of where it's defined. Okay. So if I want to do something like providing a closure inside of here, and I want to say we're going to call add up the values, we'll just say add up for simplicity's sake, okay? And I say inner, okay? So eventually we're going to create a new reference to add stuff, and then what add up is going to do is it's going to return past plus inner, okay? And then we're actually, this add stuff function, when it gets called, it's going to return add up. Okay. So it's going to return the keyword that comes out of it. So this return is actually going to just return out. It's going to call add up. So when I call add stuff, it's going to call add up, and it's going to return the value that comes out of this. And so, we can use this for some cool instantiation tactics. And this is where we're going to introduce you to this to this keyword called new. So now if I create a variable called add to and assign it to the new keyword and give the new keyword add stuff and pass that to, okay, what I'm doing is I'm saying, okay, add stuff. You are giving us a new reference. You're creating a new version of add stuff, okay, and assigning that to add to. So then we can go on and call add to with whatever number we want, and over and over and over again, it's going to reference, add to is then going to become this inner function. It's going to reference this inner variable, and it's going to add to whatever we pass it. So now in memory, we have this cool, and I'll log this in the console for you so you can see kind of exactly what's going on, and it's going to blow your mind. And this is super, super cool. So what we've done here is we've passed in this variable passed, that somewhere in the context as this runs, passed is going to become, whatever it was given. So in this case, it's going to be 2. So pass is going to equal 2 after, sorry, I shouldn't do the fat arrow anymore. So pass equals 2 on this first time we use the new keyword, okay? So if I were to log this out, pass would become 2, but we need to finish this in order to let it do its magic. Well, actually, we probably don't, but we'll play around with it in the console in just a second and demonstrate. Now I can use my add stuff function and create an entire new object or an entire new instantiation of it by saying add 3 equals new add stuff and pass that 3. So now we have 2 completely different references to this function add stuff that we've created right here. Pretty powerful. And you can do this so on and so forth over and over and over again. So if you, this is a pretty useful program, because if you say, you know, if some user clicks a button and they just want to add 2 to their project, it's just going to add 2 to whatever number they've inputted in the input field or whatever. So now how is this actually going to work? So let's actually console.log. We'll say call add 2 and pass it 4. Okay. And do the same thing with 3. And you would expect that 2 plus 2, the outcome that gets returned is 4, and then the outcome that gets returned is 5. Oh, sorry, 6 and 7, because we can count today. And then there's a question in Slack that says, is it like defining a default value? Yes. So basically, I've kind of created this sort of contrived example of, you know, what would be called sort of a constructor or a function that's going to pass or inherit values over and over and over again. So it's like defining a default value, yes, but there's no value given the first time this, you know, the first time JavaScript reads this program, it's just going to create a function that we can call and use over and over again. And it's not going to be able to really do anything out of this because past and inner aren't defined until, you know, we actually give it past and then later on give it inner. So yeah, they're sort of like default values. But yeah, that's essentially we're setting a default to add 2 by giving it 2. So that's a good question. Hopefully that clarifies sort of that. So if we run this, we get 6 and 7. So we have a closure inside of this function to the variable past. So, and we've created that through this way. So now let's actually see what happens to this in the console. So let's get a new tab here. Command Option J, and let's paste that in the console. And let's see what our console does to us when we instantiate a new version of that object. And we call add 2, and I just want to see add 2. Do I have to really call it? It's not a number because we didn't pass anything to it. So we're only going to see this. Okay, let's see what happens to add stuff. I want to open the whole object for you. Maybe console.log, add stuff. Same thing. So basically what I was trying to do is open this up and show you kind of what's going on under the hood. And I have, yeah, so add 2, what if I console logged add?
You could also try it on that Python website.
Ah, yes, I can go to, and Ty,
Python Tutor.
pythontutor.com. Yes, we've been there many times. Thank you, Ty.
Of course.
Tutor. I don't have it saved in my thing, so. Okay, so if I write code in JavaScript here, cool. Let's see what happens when I do this, and then sequentially call add 2 and give it 4. Visualize execution. Okay, so this is a really cool tool that we used a lot with the previous classes, and it helps us sort of get an idea of what the full call stack is doing in JavaScript under the hood. And I've actually gone quite a bit over. I'll talk for another couple of minutes, go through this process, and then we're just going to have to get the callbacks. I'll just go over a high-level example of callbacks in a second. So I'm going to step forward through this entire program one piece at a time. Okay? So yes, the first step that we've got this add stuff attached to the global frame. Okay? The next step is you can see that we have this sort of constructor function that is, you know, being assigned, okay, so this, we're gonna get to this later, so don't worry about it. And then add up and past. So now past is 2, right? Because that's what we called it right here with, okay? So let me go forward one more. So now the return value becomes whatever gets returned out of that function. And now we're gonna see what happens when I actually call add2 that I've instantiated. So you can see very quickly that past, the parent has past of inner, and then so that's inside of add up. So look inside of add up right here. Pay attention to this little block. So inside of add up, we actually have a closure over that past variable, and you can see that very, very blatantly right there. And then once this finishes, the return value is going to be whatever this line adds them up to be, because we return add up, it gets a closure over past, and then inner. So that's another, it's a little bit more in depth of an example, but it is a closure, and it's very, very powerful to sort of see how that can work for you. So let me copy and paste this over into the notes and go over callbacks for like 25 seconds because I want you guys to have as much time on the homework as you can today. And so, okay. So here we go. So a callback. When we used for each, we used an example of a callback. So when we pass this anonymous function here, you can basically just pass whatever variable in here that you want, right? So that's our for each function. If we were to build this from scratch, let's say we have an array of, 1, 2, 3, 4. Let's get rid of that comma. And then if we were to say, let's say const each, and I won't finish this all the way because I want you guys to be able to do this yourself. Basically, what we can do is we can define some parameters here, one of them being that array that gets passed to it, another one being a callback. So as we go through our array, so for let I equals 0, I is less than array.length, I plus plus. This is sort of what's going on underneath the hood of your for each function. So if we were to do this, and we were to say call back every single element's value, right? And then I want to know where they're defined at. So remember when we had for each, and we gave it this anonymous function here. This anonymous function is our callback. So when we call for each, you would expect that we get out of it the value to us, or the ability to give it 2 parameters of some sort of value and some sort of index. Okay, so that's what for each needs to look like. And this is sort of a copy or an example of what that's going to do for you. So for every single item in this array, call back or give some sort of return to the callback or whatever it is that you're going to need to be doing for your homework. And you can look at the tests, and when you go over it, and you'll see that each test has an example of how you're going to be using each. So if you wanted to build this, sort of iterator function to use over and over and over again in your program, you could say, okay, I have my array now. In fact, this should be called, This should be my array because we're defining it there. This is just a parameter, so you don't need to associate those two right now. But when we go to call each, you would assume that it gets our array or my array, and then that anonymous function, right? Okay, so loop over the given array and through the length of the array's times, and for every single iteration, give me back out the element and the index. Okay, so if I were to console.log element and index, you would hope that this is able to use those. So 1 at 0, 2 at 1, 3 at, whoa, we had some interesting things go on here. Oh, so 1, 2, so 1 at 0, so element is 0. Okay, let's just look at the the elements real quick. Okay, 1, 2, 3, 4. Now I want to just look at the indices to make sure that I'm doing this right. Yeah, so that works. So if I were to say, console.log, and you can do this with your console logs, you can add strings to them to label them, which I highly recommend. So element gets element, okay? And then indices, or index gets index, okay? So, and you can even space these out so they look real pretty when you actually console log them out. So something like that helps you label it. So what I've done here is I've created a function that accepts a callback as a parameter. This is a huge principle in JavaScript. It's not always the most useful in like little things, but it's very, very common in functional programming, which is what we're teaching you as we go about. So little things like day-to-day stuff like this. Let's say you had, to use, instead of wanting to write for let I equals 0 over and over and over again, you can create your own function that does that for you. And so that's really, really cool. And then you can pass that function a callback function that's going to get called, or as a parameter that's going to get called every single time you iterate over it, or do something, right? So this is functional programming 101. This is more advanced topics in JavaScript, but when we get to Ajax or fetching data from a server, you're going to be using callbacks all over the place. So passing, the ability that JavaScript has to pass functions as parameters and treat those parameters as first-class citizens. What I mean by that is so the parameter, so a first-class citizen in JavaScript would be a number, so 1, right? That's a first-class citizen. That's a number type, or a type number equals 1. Another first-class citizen would be string, so because it's a type, right? So same thing in JavaScript. Function, or anonymous function, or however you're calling this, right? Right? Is a function in JavaScript is a first-class citizen. So you can pass them around like variables. You can pass them around like arrays. You can pass them around like objects. And so that's what's super, super cool about this. So a callback is a function that you expect to be called, that you can set as a parameter that you can expect to be called back at a different time in your program. So a callback, let's get a high level, is a function that can be called at a different place and time in your application. Okay, that's a very high level definition of a callback. And since we didn't get too much time to focus on those in this lecture, I will be sure to set aside some time for that. So I'm gonna go ahead and release your guys' homework, because I went super far over, and I hope this was at least a little bit enlightening. Hope you learned some good stuff. And then we'll get you some pairs and things like that. Or let's see, what are we? I'll double check the schedule and we'll make sure that we're in the right place.